So here's another kind of abstract question about power series. Let's suppose that a power series is known to converge at the numbers 15, 17, and 18, and that it diverges at 13, 19, and 21. I'm not saying those are the only places where the series converges. I'm saying those are the only places we know. So the question is, which of the integers from 14 to 18 could be the center of the series? The relevant principle here is that a series the interval of convergence has to extend an equal amount from the center. So if that's the center from the series has to extend r in that direction and r in this direction. And then there are these endpoints. We don't know whether they're soft endpoints or hard endpoints, or in other words, they're excluded or included, or if it's some combination of excluded and included. We can tell is that once we've established that the radius of convergence is at least a certain amount, we can't have any points of divergence within that radius of convergence. So let's examine each of these points. We're going to look at that one, that one, that one, that one, and that one. Okay, so could 14 be the center of the series? The answer is no, and let me show you why. If 14 is the center of the series, then what that means is the interval of convergence has to extend at least that far. So in other words, we'd have to have a radius that's at least 14 to 18. In other words, it has to be 4. Could actually be higher because we don't know, let's say, what's happening at 18.5. But we know the radius has to be at least 4. So what that means is that if I try to go 4 in this direction, look what the problem is. I'm including this point 13 that I know is not within the interval of convergence. So 14 cannot be. 14 can't be the center of the series. Okay. Let's try 15. Does 15 work? The answer is no, and really for the same reason, because if I put the center at 15, then I have to go at least as far as r equals 3, and when I go out here down to 12, I've got this point where the series diverges. So I can't have any points where the series is known to diverge within the radius of convergence. So 15 is not a candidate. Now let's try 16. So if 16 is the center of the series, then I know that I have to go at least here. I have to go to r equals 2. And if I go 2 in this direction, then it certainly could be the case. We can't rule it out because we don't know what's happening at 14. So there's nothing here that prevents this from being the center of the series with a radius of convergence of 2. This is a plausible scenario, and we're going to say that 16 is acceptable. So let's see. Let's look at 17. Does 17 work? If 17 is the center of the series, continue doing this in red. If 17 is the center of the series, then we know that we have to go at least that far. Well, actually, let's go in the other direction. We know that we have to go at least this far. We know that we have to have a radius of 2 to get down to 15. And now we have to have, which means that the series has to be able to extend at least 2 toward the right. Now you might look at this and say 19, that's excluded, that's divergent, so I can't reach that far. But wait a minute. Isn't it possible that the interval of convergence could have could be included, could have a square bracket on that end and a round bracket on this end? And the answer is yes, that's possible. So it is possible for 17 to be the center of the series. Now how about 18? If 18 is the center of the series, then we know that we have to extend at least down here to 3. And we see then what the problem is, which is, although I certainly wouldn't have to include this endpoint, the problem is that I then have a point of divergence at 19. So this is so 18 cannot be the center of the series. So we see now 16 and 17 are possibilities, 14, 15, and 18 are not. That's the guiding principle here is that you have to figure out what the smallest radius of convergence could possibly be by looking in one direction, and then go in the other direction and see if you encounter any points of divergence, being very careful about endpoints because you always have the option to exclude an endpoint from the interval of convergence.